like that. These are the graphs. This graph is force with time. This is the force along the y-axis and x-axis. So this is the force time graph. This is the force time graph. So what is force time graph? The graph between the force and time, that is called as force time graph. So this is the method is using in the case of impulse. Impulse. What is impulse? Impulse is equal to the product of force time. The product of force time. This product is called as the what? Impulse. Okay. The concept is, okay, first you have to solve the question one by one. First, which concept it is a familiar. You have to identification yourself in the exam. So this is a force time graph. This is an impulse concept. What is impulse? Impulse, how can we define? The impulse is what? The impulse is, okay, impulse means the large amount of force is acting on the body with a small interval of time. That is called as impulse. The large amount of force. This is the large amount of force acting on the body with this very small interval of time. That is called as impulse. For example, cricket batsman to hit the ball. Okay, so with large force, with very small interval of time, catch the ball. Okay, so that is a force, large amount of force with very small interval of time. That is called as what? Impulse. So the large amount of force acting in very small interval of time, that is called as impulse. Now, so by the graphical method, how to find out the magnitude? Because impulse is a vector quantity. Okay, impulse is a which quantity? It is a vector quantity. Vector quantity. So vector quantity means it is a magnitude direction. So in graphical method, this is a graph. So in graphical method, area is to find out the magnitude. Area is the magnitude. Area is the magnitude. So direction of the impulse is along the direction of the force. Okay, along the direction of force. Along the direction of force. Along the direction of force. Okay, so in the question, so asked. So in the question, what is asked? It is asked for the impulse is highest in the case of situation dependent. So on this graph, which is the highest impulsive force? So the magnitude of the impulse is found out by using the area. So which is the area is higher? That is a higher impulsive force. Okay, you have to calculate the area one by one. Okay, first one, this is the what? A rectangle. So in this rectangle, area is equal to what? Take one by one in the diagram 1. Okay, in the diagram 1, that is area is equal to what? In the diagram 1, area is equal to, so it is a rectangle. So length into breadth, that is a 1 into 0.25, that is equal to 0.25. So force Newton, time is second. In the first diagram, then second one area. Okay, so this is height is given, but it is a what? Which type of force? This is a constant force. Okay, now look at this one. This is a constant force. By constant force, you have to length. So that is in the constant force, you have to take 1 into 0.25. So then, but this is a force is variable force. So in this variable force, you have to bifurcate into the small segments. So this is the bifurcate into the small segment. This is a right triangle. This is a right triangle. So area of this one, area of this two, add together. Okay, so area of the first one is half into base into height. Height is 3, 0.3. This one is 1. So that means half is a common of base into height. That is 1 into 0.3 plus this side it is 1 into 0.3. So the final answer 0.3 plus 0.3 0.6. Okay, so that is equal to half into 0.6. That is final answer is 0.3 Newton second. So this is the area of the second one is 0.3. The first one is 0.25. Then third one. Okay, which is a all sides are equal. Look at the diagram. This is a 1, 0 to 1. This is also 0 to 1. So that is area is how to find out? A cube. That is A cube. That is equal to 1 cube. The answer is 1. So this area is 1. Then this is a right triangle. This is 90 degree. Right triangle. It is a formula is half into base into height. Area is equal to half into base 1 into height is 1. The final answer is 1 by 2. This is a 1 by 2. So which is the highest impulsive force? Look at these 4 diagrams. So these 4 graphs, not for diagram. So in these 4 graph, which is the highest impulse? Is it 0.25, 0.3? Okay, in the option, first option, 1, 2. 1, 2 is highest? No. Option 1 is not. Option 2. Option 2 is third and 1. Third and 1. No. Option 2 no. Because third is highest, but 1 is only 0.25. Small. Maximum small. Option 3. Third and fourth. Look at this one. Third and fourth. Okay. Then fourth option. The fourth option is fourth only. Fourth only. This is a mediate. It is an intermediate value. So the option for the correct answer is third. Is the correct answer. Third is correct answer. Okay, so this is the first question on the basis of impulsive force. Okay. This is the problem. This is the gun. Okay, so in this gun, okay, this is the gun. So then in the gun, the shell of mass 200 gram. This is the shell. The mass of this shell is equal to 200 gram. Correct? 200 gram. Then, so mass of the gun. The mass of the gun is equal to 100 kg. 100 kg. If the module speed of the shell is, okay, if we fire, then it is the speed is how much? The speed of the shell is equal to 80 meter per second. Okay, so then recoil speed. Listen here. So on which concept is familiar? The first one is concept. Which is a concept is familiar? Which is a concept? So this is the gun. When you fire the shell from the gun, so This is the speed of the shell in forward direction, correct? What about the direction of the gun speed? The gun speed is in opposite direction. Opposite direction. So on which concept? That is a law of conservation of linear momentum. That is a Newton's third law is obeyed. So that is a concept is what? Law of conservation of linear momentum. Linear momentum. So what is the statement? Law of conservation of linear momentum statement. If the external force is acting on the body, this is the body, correct? This is the body. If the external force is acting on the body is 0, the momentum remains conserved. That means the momentum remains constant. That is the statement of law of conservation of linear momentum. That means if the external force is acting on the body is 0, so then what? Its momentum remains constant. So that means the rate of change of momentum is what? 0. So this is the statement of law of conservation of linear momentum. So that means initial momentum is equal to final momentum. Okay, so this is the concept. Now you have to solve this one by using the concept of this one. So that is concept is understood. Okay, concept is understood. That is a initial momentum is equal to final momentum. Okay, initial speed of the shell. The shell is inside rest condition. That is the initial momentum is 0. Then final momentum. So final momentum, it is a shell plus speed of the shell. That means mass of the shell, speed of the shell plus mass of the gun, speed of the recoil. So then the speed of the recoil is equal to, so this becomes minus mass of the shell, speed of the shell divided by mass of the gun, that is equal to negative sign. So because it is the backward direction, so then minus 200 into 10 to the power of minus 3 into speed of the shell 80 divided by mass of the gun 100. So 20 get cancelled, 8 2 are 16. Very easy. Okay, 16 10 into 10 to the power of minus 3. So that is point shift ಮಾಡಿದ್ರೆ 16 into 10 to the power of minus 2 ಆಯಿತು. So ಹಾಗಾದ್ರೆ in the option, so 16 centimeter per second, because so look at the option 2, 8 centimeter per second ಇದೆ. Second one, okay, not. Third not. 16 meter per second. 16 meter per second is no. So that means it is the answer for 16. It is centimeter second. This is the answer. So the man is standing. Mass of the person. Okay. So the mass of the person is 80 kg. Okay. So then So the mass of the trolley 320 kg. Okay, 320 kg. So then person speed is 1 meter per second. So what about the displacement is covered from the man with the time is equal to 4 seconds. Okay, this is the question. So man is standing on the trolley. Okay, the man is speed 1 meter per second. Okay, so then this is also law of, it is also concept is what? Law of conservation of linear momentum. This is the concept. Okay, the concept is remain same. Okay, now the man, it is moving with the speed, the trolley is moving with this speed. The momentum of the man is in forward direction, the whole system is in backward direction. So that means momentum of the man in forward, forward direction is equal to momentum of the system because I am standing in trolley, I am forward direction, all the system is backward direction. Okay, so momentum of the system backward. So momentum of the man, the mass of the person, speed of the person is equal to the mass of the trolley, speed of the trolley. Because you have to find out the relative velocity between man and the ground ಅಂತ ಕೇಳಿದಾನೆ. ಹಾಗಾಗಿ you have to first ಗೆ ಏನು ಮಾಡಬೇಕಾಗಿದೆ, you have to calculate the speed of the trolley. So by using this concept, the speed of the trolley ಎಷ್ಟು ಬರುತ್ತೆ ನಮಗೆ? So the speed of the trolley is equal to mass of the person, speed of the person divided by mass of the trolley. So mass of the person 80 into speed of the person 1 divided by mass of the trolley 320. So 1010 get cancelled, 8 1 jar, 8 4 jar. So that is 1 by 4. The answer is 0.2. So it is meter per second. So the speed of the trolley, speed of the trolley. So speed of the trolley is of the speed of the trolley 0.2. Speed of the person is 1 meter per second. Okay, that means the relative velocity of the person with respect to ground, because the relative velocity of trolley with respect to ground is 0. Correct? Okay, so that means the relative velocity of the person with respect to the ground is equal to 1 minus 0.2, because this is the person speed, this is the trolley speed. When the